name is Anyone, and I'm the founder and CEO of Prescient Devices. For those of you who don't know us, we are a technology company based in the Boston area. We work on low-code software for distributed IoT systems. We've been working in IoT for a long time. We worked on a different venture starting in about 2010 on low-power IoT systems in the early days of IoT. And over the past 10 years, the IoT landscape really has changed a lot. I would say there are three major changes in this space. The first one is the rise of edge computing. So now increasingly, computation is happening at the edge, very close to where your machines are, where your data is. The reason for that is because there's so much data now. There's so much data now that it's much better to divide and conquer, do it locally at the edge. It's better for reasons of latency, better for reasons of reduced bandwidth, better for security, so edge computing is happening very fast. And one of the drivers for that is the increased capability of edge hardware. So even back in 2017 or so, a typical edge gateway has about 256 megabytes of RAM. This is industrial grade gateway. And today, just 3 or 4 years later, the new gateways coming out have about 2 gigabytes of RAM. So 10x increase in the amount of memory in a short span of time. Amazingly, at pretty much the same price point. So this allows us to do a lot more sophisticated analytics and computation at the edge. The second major shift is sophisticated analytics capabilities like AI and ML. That enables us to solve a lot of problems. So for example, many of the solutions we have uses sound, uses cameras, machine vision. It's almost like now you can place a little person, close to where the actions are and watch what happens. It's pretty incredible what kind of analytics we can do today. And the third major shift, I would say, is the rise of low-code development. The reason for that is because if we look at who uses IoT and AI in enterprise industrial applications, it's engineers. It's not sort of an end user, but it's engineers who need to customize, who need to configure their systems, and engineers need programmable solutions. Until today, even though there's a lot of technology, very good technology available in the IoT and AI space, they are hard to use. This is a problem we continue to face today. And with low code, with the right low code architecture, we can enable engineers to work on this type of solutions efficiently. And that's, in my opinion, is really going to change the landscape of IoT AI adoption in enterprises. So that's the stuff that we try to enable. And we think that working with IoT, working with data, it's going to be an essential, necessary capability for all enterprises. And that's another reason why low code is very fundamental to the space of IoT. So with that, I'm going to introduce the speakers today. So we have Pablo Acosta, who's the VP of Engineering at Prescient Devices. Pablo is a veteran in technology. He's an expert spanning many different technology spaces, from hardware to system to electronic design automation software to industry standards. He's also, been a friend with me for over 20 years. We actually went to school together, graduate school together. We sat in the same office. We worked at an analog devices together for many years. We went climbing together. So we know each other very, very well. We also have Ashish Yadav. Ashish is the director of software. He's responsible for the full stack development from the cloud all the way down to the edge. But he's not just a software expert. He's also very well versed in embedded devices as well as machine learning. So today's webinar's format is we will have a short presentation followed by a Q&A, followed by a demo. And if you have any questions, please enter your question into the Q&A panel anytime. We'll try to answer some of them in line, but we'll also have live answer session during the Q&A. We also have a small questionnaire. If it's relevant to you, please fill it out now. We'll close it shortly after the presentation starts, and we'll share the results. Soon. And for those of you who came in later, I want to say that we started to use Zoom webinar, and there's some mechanical issues here. So some of the names don't show up correctly. We apologize for that. But hopefully the content will stay relevant to you through the webinar. And with that, I'll have Pablo start the presentation.
Thanks, Andy. Thanks for the introduction, and hello, everybody. So as Andy mentioned, what we have on the docket today is two parts, an overview of what is Node-RED first, and then the scaling challenges that happen when you try to scale Node-RED and the workflows associated with that, and then a sort of a compare and contrast with our product, Prescient Designer, how that addresses the issues in scaling Node-RED and in general IoT applications, and how that also allows for extreme agility in development of the solutions. We'll pause for Q&A at that point, and then I'll jump into the always exciting live demo where nothing is going to go wrong, of course. And we'll have another opportunity for Q&A afterwards. All right, so that's a plan. Let's get rolling. To level set everybody, because maybe some of you are not terribly familiar with Node-RED, which is the tool we build upon. It's a graphical development environment for event-driven applications. At that mumbo jumbo means that you don't program your IoT application in text editor and with lots of curly braces and parentheses and pulling your hair why it doesn't compile. You do it in a graphical way with blocks and connecting blocks. And it's event-driven just because in the real world, things don't happen all the time, just happen, say, when someone clicks a button or when a sensor in a machine determines as an alert. That is an event, and that event makes things happen. It's a well-established project. It started in 2013, actually at IBM. And the shoulders upon which we build our tool primarily are Nick O'Leary and Dave Conway-Jones. Huge thanks for these two individuals who have put a lot of time, energy in creating Node-RED and fostering a vibrant community. It's a very well liked and popular project. As of 2019, it had more than 2 million downloads, and it's built on top a rock solid technology. Node.js is the underlying technology, and that's if you haven't heard of Node, it's used essentially in every Fortune 500 company. It's super stable, industry grade, and as the Node-RED is not just the program itself, but it's also a vibrant community where people contribute to the application itself, but also contribute blocks that you can use in your code. There are more than 3,000 of those. And for the nerd among us, it has about 11,000 GitHub stars, which put it solidly in the top 20% of all GitHub projects, which is amazing. So that's sort of the base upon which Prescient Designer is built. And here's a typical screenshot of Node-RED, where you have blocks on the left that you can use, and think of this as functions in a library, for example, and then you drag and drop them into the middle, which is called the workspace, and you connect the blocks, and that's the way you program. So it's low code. It's as I mentioned, you don't have to be a software engineer to program this. And it's mainly targeted, I would say almost exclusively targeted to run in a single device, meaning you somehow log into a machine, to an edge device, you install Node-RED, and then all the development that you do is local, meaning you do it in that machine. And if you want to update the program, which in Node-RED parlance is called a flow, you either copy a file, or if you know how to use how to make an HTTP call, you do that, or you just essentially somehow access the editor, which is through the web browser, into that machine. So you have to have network connectivity to that machine if you're not logged into the machine, and you program there. So that's Node-RED, single machine, low code, all good. The problem is that IoT systems are not single device systems. They have many, many, many devices, hundreds of devices, with one or more sensors connected to each of those devices. So if you're trying to use Node-RED in this system, well, that is really challenging. So first, assume that you somehow installed Node-RED in all those edge devices. Now you have to deal with a myriad of technical issues, none of which have anything to do with the application that you have at hand. For example, say you want to do vibration monitoring. Great, but first you have to somehow connect the devices. You have to worry about security in that connectivity. You somehow have to address the issue of how do you modify or update the software that's running each of those Node-RED instances. So you're talking about orchestrating, deploying somehow. Then, of course, you might want to do some cloud processing, right? So a lot of, as Andy mentioned, a lot of power is in the edge devices, so you can do more and more edge processing. But also you might want to do or have to do some processing in the cloud. So you have to implement that somehow, potentially different technology stack. You have to have your cloud infrastructure. You have to design that, maintain that. Then if you have to visualize it in the dashboard, that's a separate thing that you have to deal with, and a separate technology stack and a separate skill set. And all of this have to have some sort of user interface. Like if there's an operator that needs to do something, then you have to somehow provide a user interface for that. So the breadth of this technology stack that is shown here is enormous. Different skill sets, different set of requirements, and even for a really skillful application engineer of a global Fortune 1000 company, which has groups in that company that deal with all of this, even for him, we have first-hand experience that even for him, this is overwhelming. So scaling from one device to hundreds of devices, it's a real complex issue. And currently, people that are attempting to do this, as many things in technology, there are many ways, but one of the most popular and modern ways to do this is to try to say, well, I'm just going to containerize the edge. I'm just going to, first, I'm going to install the container software, orchestration software, i.e. Docker, in all of my edge devices. And then I'm going to have a development workstation where you're going to develop the Node-RED flows for all the devices. And mind you, this might be one or many different type of flows depending on the device. So you have to have a sort of local development environment. And then once you think you're done with the development, you say, okay, now you have to deploy it. But of course, first you have to build a container. And not just the actual process of building the container, but writing the script files and the build files so that you can actually build a container. And once you do that, and that could take a long time, just the actual building the container, even assuming you have the build file already. Now you deploy it, and there's a myriad of options here, and all of them with pros and cons that you have to navigate. Assuming a successful deployment, now you say, great, I have my edge application done, presumably, maybe. And now you go to your cloud application. Now you have to perhaps a completely different set of tooling to do that. That could take a long time. Then you have a Azure or AWS expert, right? Because you do have that, sure. And designs the cloud infrastructure. And after that, you can actually test your application. And now you realized, oh, I made a mistake. So you have to start all over again through all this lengthy, laborious, and time-consuming process. And one of the things is that is bad about this. One of many things is that all your development is local. It's really hard to collaborate with people. I mean, you have to sling files around or have some other esoteric ways for other people to see what you're doing. So this is obviously not something conducive to an agile development, and particularly this is particularly relevant in IoT, where you perhaps know where you're starting, but once you get the data, once you start seeing what you can do, you're naturally going to want to do different things and things that you never thought you could do or never occurred to you. So you need to be able to have to iterate and change, optimize frequently and quickly and painlessly. So that is what Prescient Designer is here to address. This, no joke, is the flow that you have in Prescient Designer. You provision the device with a one-line script, and that is hopefully, I mean, you have to log into the device, same as we're now ready to install the orchestration software, but with Prescient Designer, that's the last time you have to log into a machine. You provision it, done. The machine shows up in Designer. You design the flow, your program, your application in Designer. And mind you, this is in one place, you see everything. You see the cloud component, the cloud application, the edge application, the dashboard, the control panel, all in one place. So you design that in one place, and it's a SaaS application. So it's easy for other people to see what you're doing and to collaborate. When you think you're done, you click a button that says deploy. The flow, all the flows, all the modules, everything gets deployed seamlessly. And then you see if you need to optimize, you need to iterate, you need to change something. You're still in Designer, you change it as you see fit, hit deploy, and off you go. So first of all, this is painless, it's quick, and allows you to concentrate on the application itself, not on the IoT system. You just deal with the problem at hand, and that's what's empowering. It enables engineers, domain experts, to scratch their own itch, to actually solve the problem, and you don't need an army of software developers, DevOps people, cloud experts to attempt to build an IoT system. How can we do this? Because building on top of Node-RED, we add a whole host of features that make this industry grade and enterprise ready. Chief among them is distributed programming, and I will touch upon that more later. But it essentially allows you to, in one place, assign different blocks to different machines at the edge and then quickly deploy. As I mentioned, it's cloud hosted, so it allows collaboration. It's everything, all the communications between the cloud and the edge or between the edge devices themselves, it's end-to-end secure, which is one of the key concerns of IoT. It has built-in communication, meaning that, and you'll see this in the demo, the user does not have to worry about how these two things are going to communicate. How do I need to do? What do I need to do to make that happen? You'll see it's just kind of like connecting two blocks, and the magic happens. as I said, because it's a SaaS application, it allows for remote collaboration. We offer a bunch of template solutions for, say, machine vision, for vibration monitoring or predictive maintenance. And this is to help customers ramp up, because there's nothing like, you don't want to be in a situation where you get a tool and then you're having the sort of the white page, blank page problem where you say, great, now what? So these are great starting points for the typical use cases in IoT. We have a bunch of nodes that we have written that are proprietary, that provide you with a lot of analytic functionality, so that you don't have to write them yourself. We have rollback and recovery, because sometimes if you have a badly written, but perhaps contributed block that you deploy, sometimes the edge node read will stop. And again, you don't want to have to access to the machine and try to debug what happens. You can automatically, and see in the demo, you can just say, hey, roll it back to a safe state, because I know that the last deploy did not work for that particular machine. And last but not least, we also provide certified solutions in terms of hardware and sensors, meaning that we make sure that when we recommend a particular setup, hardware setup, we know it works. Funny joke about standards that really, they're supposed to be interoperable, but in practice, most of the time they're not. So everything has its own quirks. So we make sure that if we say a particular setup is recommended, it's tested and certified that it works. So all of this functionality and more, makes it so that, again, the user only has to look at and think about the problem that he or she is trying to solve, and not all of this complexity. We take care of all that for the user. So the key enabler for this is what we call distributed programming, which is the concept of having a cloud and edge application in one place. And you can see here, this is a simple example where we have 3 device groups, and each group is running a particular application. Say 100 devices are running detecting for vibration. And you can see here, this is the application inside this block. Whereas this second set of 100 devices are detecting over temperature. And this simple application is running inside this block. Whereas the rest of these hundreds of devices are just monitoring pressure. So you can very quickly assign machines to blocks, to applications in Designer. And all of this sits in the same flow, in the same place as the cloud processing. So you can see here, there's a block that says cloud processing, and it's running some analytics. And the output of that goes to a control panel where you can visualize and interact with the data, and a debug output. But again, all this is in one place. And you can see the blue wires here are a clue that there's a transition between one device and another. In this case, between edge devices and the cloud. But you understand that you can also connect an edge device to another edge device. So this is giving you a clue of that, and also this connection indicator, that these are applications running in hundreds of edge devices, seamlessly connected to the cloud. You see it on demo, the user only has to just wire this up, just connect this little square with this little square, and magically now these sets of devices, these hundreds of devices, are connected to this cloud processing block. So this is the key enabler to vastly simplify writing an IoT application, provide agility, and focus on the application at hand. So do you have a project? Does this seem like something that can be helpful to you? We encourage you to get in touch. Usually, we like to do a technology assessment and see what your project is and how we can help you. Then you will get access to the designer, develop a proof of concept, and off you go. So we highly encourage you to contact us. Our website is there. You can let us know if you're interested, and we'll certainly start working together. So that is the part one. And so I will pause. First, I should remind everybody that in our website, and you can see the link here, we have a white paper, an application note, specifically targeted to Node-RED users, where it shows you how you can transition from Node-RED to Prescient Designer very easily and gain access to all the cool, interesting, and valuable features that Designer has. So with that, I will pause, and Andy, I don't know if you let me know if there are any questions that are outstanding and that we can answer.
Yes, thank you, Pablo. So this is a short introduction. I think you guys will get a better idea of what the software looks like once we show you the demo. Now, there are a bunch of questions here. So Pablo, there are two that are relevant to each other. The first one is, can we install any third-party nodes through the palette manager?
The answer to that is yes. Anything that is accessible via the palette manager is fair game. When you deploy, we figure out what nodes need to be delivered to the edge. So there's a whole complex module management behind the scenes to make sure that the nodes that you're using in the application get delivered to the right edge devices. So yes.
Okay, the second question, I did give a brief answer, but I think Pablo, you can elaborate on, is how do you deal with native node modules? So I explained a little bit about, our edge structure where we actually have a runtime plus a Node-RED, and the runtime can install node modules or other applications. Yep. And that's something I think that's fairly unique in our system, right? So maybe you could elaborate a little bit on what we do at the edge to make it more reliable, to make it easier to install applications, etc.
Yeah, so in every edge device has a local copy of Node-RED where the flows that you design on the cloud get delivered to. But we have a separate application, which we call the runtime, that controls that Node-RED. So, and that has many advantages, one of which is, as I mentioned before, sometimes you install a module from the palette manager, and it has happened to us, it crashes Node-RED, right? It's a rogue module, not necessarily maliciously, but it's not high quality, and it crashes Node-RED. That's fine. We have the runtime, which has the command channel to say it restarts Node-RED, it puts it in a safe state where you can redeploy again. And so that is our basic architecture. And yeah, as I mentioned before, you can install any module that you want of the palette manager, or you can write your own. I mean, you can have your own private registry, which is particularly relevant if you're enterprise or a particular corporation where you have an IP that it's proprietary and it gives you a competitive advantage. You can also have a private registry and install modules from there. As I said, we have a quite complex and efficient module management and figuring out which modules need to be installed where. And I see another question about whether it's optimized for low bandwidth cellular connections. So the answer is yeah. So, and you see in the demo, we only, depending on, you can put the subflows and assign the subflows to devices in whichever way makes sense. And the designer is smart enough to know which of those connections are local, meaning they're inside different modules inside the same device. So obviously those don't go to the network at large. And deploying itself, we only deploy when there's meaning we only change a flow in a device when there is an actual business logic change. Meaning if you just move a module like to a different position, but you don't change the wiring, that you haven't changed any of the logic of the device. So we don't deploy there. That's just one example of the many measures we take to minimize the bandwidth consumption. And starting off with the fact that the flow itself is not a very large application. Now it's up to the customer to, if you have large amount of data, it's up to the application writer himself or herself to figure out how much you want to send to the cloud or to another machine. In that sense, obviously, as much processing you can do on the edge to decimate that payload, the better you're off if you're in a metered connection, obviously. But we've done all the smart things that you can think of to minimize, in terms of the management and deployment, the bandwidth that we're consuming.
So Pablo, if I may interrupt, what you mentioned, one thing is that deploying JSON flows is much more efficient than deploying containers, right?
Yep.
Even if it's differential containers, I think flows are still a lot smaller. Now, you also, I think, spend quite a bit of time looking at optimizing for cellular, Node-RED environment, right? Because if you remember, if you use Node-RED or if you use MQTT, there's a lot of pinging and there's a lot of data just idling. This I think nothing to do with the flow. Just the idle times, you have data packets going through back and forth, right? So we spend a lot of time optimizing that. Can you talk a little bit about if somebody just uses regular Node-RED at the edge, say using MQTT, what are some potential data problems they would have through sort of a bandwidth limited network versus what we have done to improve that?
Yeah, so the underlying communication is MQTT, but MQTT has a lot of quirks and a lot of settings that you can delve into. And one of them is that, like many communication protocols, it has some sort of keep alive mechanism, where every now and then the client says, "Hey, I'm still alive, don't close the connection." And just that by default is every 30 seconds, if I recall. So every 30 seconds, there's traffic, right? And that in a meter connection, 24/7 will kill you. You'll consume a lot of bandwidth just pinging. So that's one of the many details that we have taken care of to make sure that you're not unnecessarily pinging, while at the same time keeping the connection alive, so that you don't have to, when you deploy, you don't have to reestablish that connectivity. There's a lot of fine-grained details that are 5 levels deep in the technology stack that we have addressed, so that even if it's a wire connection, it's speed, right? It's even a fast deployment will allow you to deploy more often, to be more apt to make changes, because you know that it won't take half hour to deploy, right? So that goes to the whole agility of development.
Great. So we'll take one more question, then we'll move on to the demo. And Mark, I don't know if you have the results from the question from the poll. If that's meaningful, you could maybe display that. We probably won't talk about it. So the last question, Pablo, for you is: do you have a on-prem offering?
Yeah, the software can be run on-prem. There's a designer can be installed on-prem. That's not a problem. I think if I expand on that, if the concern is, for example, data protection, we all even run on the cloud. As I said, all the communication between the edge and the cloud is secure, and you can have your own MQTT broker, or you can run your own broker so that the data itself never leaves your own network. But installing Designer on-premise, yeah, it's totally doable.
Great. So let's now move on to the demo. I'm looking forward to see it because this is an interesting one as you promised. So
I did.
I'll give the
I said it
floor
was going
back
to be
to you.
exciting just because it's a high wire act. Let me switch to the demo. If I can find my browser screen. All right. All right. Do you see my browser? Do you see my browser? Yes, no? Perhaps?
Yes.
Okay. All right. So this is Prescient Designer running on the cloud. The first thing that you notice is, as any cool application in 2021, is dark mode, right? That gives it immediate credibility. And I'm joking, of course. As Node-RED, you have all the nodes, all the things that you can drag and drop on the left, and you drop it into the workspace. And here on the right, you have something that's unique to Designer, which is the list of devices you have provisioned. On top, in this bluish card, is the SaaS part itself. So this is the cloud component, and you see available memory and available disk. And below that, you see the one card for each of the devices you have provisioned. In this case, obviously, in the interest of time, I provisioned a bunch of devices, which I used in developing Designer anyway. So each device has a device name, whether a status, whether it's connected or not connected, and when was the last time it was responded to our ping, which is the sort of keep alive ping is programmable too, obviously, again, with the theme of if you're in a meter connection, you don't want to be pinging every minute. Available memory and available disk. And also an interesting fact is this little lock icon. In this case, it's green and closed. Having us hosted SaaS application means that we know what the quote unquote truth is in terms of what are the flows that each device should be running. So we can compare the flow that machine is actually running with the one that should be running, which is the one we have in Designer. And if they match, you get a green lock. And if you don't, you get a red open lock. And this can be, a mismatch could be because someone did not get the memo that Designer is cool and you don't need to log into a machine. So they logged into the machine and changed the flow, for example. And that will alert you, or it could be more malicious. Part of the sort of our security offerings that you know immediately that the edge flow does not match what you have in Designer. And here in the affectionately called hamburger menu, you have some of the management options. For example, if you're not using the machine anymore, you can decommission it so that its card disappears. As I mentioned many times, if for whatever reason, say there's a buggy module that you have installed and it's crashing Node-RED, you can reset it. So you put it in a safe state where you can redeploy again, perhaps taking out that module that was crashing it. Or if you actually change the flow directly on the machine, which we don't advise, but for whatever reason you did that, you can just redeploy, meaning that you send just to that machine the flow it should have. So this is the device side panel, and this little icon essentially just repings the machines. So let's start building something. So this is an inject module. So I'm just gonna call the source, and And I'm gonna set it to my name is, okay. And now we are going to say put as change node. We're gonna connect it. And let's call it who am I? I'm gonna set the payload to a JSON add expression that is say message dot payload, and we're gonna the cloud. Okay, so right now nothing super exciting. I'm just gonna connect this and just call output. Let's say output. All right, connect, deploy. So far, I've done nothing that is you can do in Node-RED. In this case, there are no devices that need to be updated. If I inject, I get my name's in the cloud. Okay. All right, so let's do something slightly more exciting. So now I'm going to turn this into a subflow. I can deploy again. All is cool. And here is part of the magic. So when you edit this subflow, now you see that every subflow has this device ID selector. So this is how you associate a flow with a device, meaning I want this flow to run, and if I click here, I see all the devices that have provisioned. I say, well, let me run it in this CNC machine, okay? And I deploy, and of course, something happened. Oh, do it again. It's deploying, and then update the machine. Now, the CNC machine is connected. And if I run again this, you'll notice that there's a little bit of delay because from the moment I clicked to the moment the message appeared, because it went through the network to the machine, added is the cloud back into the cloud. And you notice that these wires changed to color. Now they're blue, because that, again, as I mentioned, means that there's a change of device from one device to another, from the cloud to a device to the cloud again. Now, just to prove that this is actually run in cloud, you can do something slightly more involved and say each subflow in a device has a device ID environment variable associated through the entire flow in the device. So if I just say, if I'm going to add device ID here, and I deploy, I go back, I click, you get a deployment error. Of course you do, because it's a live demo. Okay, I think this should be fine. There we go. See, my name is CNC machine. So each subflow can identify its own, that's running on the machine, can identify which device it is. Now, to show the smart deployment, let's add something else. Let's say we add another block here and say message.payload. We're going to add some pizzazz. We're going to add some exclamation points, okay? And let me connect that here, that here. think it was, I had a space here. Okay. Now, if I click here, nothing happened. Oh, this is cool. There we go. Just to prove that this is live. Okay. So now let's turn this into a subflow. And now let's associate this to the same device. Notice the subtle difference. The blue wires are here. This connection is not blue because it's within the device. These two subflows are running in the same. This wire, this connectivity is between the same device. So that does not leave, as you know, messages going through this wire do not leave that device. And this also exemplifies that you don't need to have one subflow where all the logic that needs to be run in a device is. You can partition the subflows that run in a device however you see fit. You can have one flow per device, you can have multiple flow per devices, you can have a device within a device. So it's all good. And if I just turn it quickly back, you can also very quickly scale. So let's say you like how the logic is working and you're fine with that. Now you can run it in a bunch of devices. And here it's updating that flow into a device group, meaning it's just not one device, but multiple. And what you'll see here is that some could not have been updated. Sometimes it happens in network. So you can, oops, it will tell you which devices were successfully updated. And this, in case the water pump 2 could not be updated, probably it was a network connectivity issue. Let's try again. Okay, so now you will see is that there should be about 5 messages coming out when I click here, and they all have the machine that they're associated with. So now I turned a device that run in one device very quickly into, I scaled that to 5 devices. And you don't have to, if you have hundreds of devices, of course, you get carpal tunnel syndrome if you try to click on all those devices. You can go to this device, and what you saw here was a select from list. But you can also import the devices that you want to run from a file, right? So you can say take that from a asset management system. You say, oh, these devices are in this building. You import that file, and you associate it with Subflow, and you run it. So very simple demo, but shows some of the features that Designer has to allow for quick scaling and quick deployment and agile development. And I'm mindful of the time. I could go on forever, but I want to leave a few minutes for any questions or comments that people may have before we close out.
Okay, yeah. So Pablo, just to let you know, the last few minutes when you were doing the demo, your Wi-Fi was a little bit lagging. So the magic sometimes was, I'm not sure if everybody saw everything, but the idea is basically you can turn one subflow or just one module into many devices, either by selecting them or reading from a database or a file. So that makes it very easy to deploy to a lot of devices. I think this is a basic demo, but it is very interesting to show that capability. We'll have some other fancy demos, but then we wouldn't have time to like, show the fundamentals of the software. So I think this is really cool. We do have some questions. The first question is, what have you done with ML at the edge? That's a good one.
Sure. We, for example, have done a Fortune 500 insurance company, for example, wanted to monitor the state of the OS and Y valves. These are the huge valves that go in pipes for sprinklers, the ones you actually have to manually turn. So they wanted to, for example, determine if the valves were open or closed. And before they had to actually have a human being go and look at each valve and record the state. And of course, there's only so many valves that you can check per day, so they would be checked infrequently. So we put a camera connected to an edge device that is running a classifier at the edge, and it updates alerts if a machine changed, if a valve changed state, for example. But you can also, it's coupled with a whole dashboard where, at any point you can also just select which valve you want to see, and you click an icon, and it takes a picture, sends it to the dashboard. But the inference is run totally at the edge. So that's one example of things we've done with machine vision.
So we pretty much support TensorFlow Lite on all the devices, other than maybe the ones that has less than 256 megabytes of RAM, right? So
yeah, and also TensorFlow. It's interesting. So we even support some configurations or some processors where there's not a readily compiled TensorFlow to run on, and so we've taken the painstaking and harrowing work of compiling TensorFlow for those architectures. So when you provision the device, it kind of installs the right TensorFlow.
Okay. Here's another question. I think it's very relevant to Prescient Designer. The question is, in the examples you just showed, the fleet of edge devices are running the same project, basically, right? The 5 devices.
Yes.
How do you manage completely different projects or applications? So if you want to, have another group of devices doing different things, how do you design that?
Yeah, I think I showed that in some of the slides. I mean, say you can have this is Subflow 2. You can have, say, Subflow 3, and this is a completely different application, right? So I guess it depends the scale. What do you mean by project, if it or application? If you can put in a Subflow, you can have different Subflows here in a tab, or you don't have. And this is a point that I tried to make, is you don't have to have a device, a Subflow that's associated with a device in a tab at the top level. You can. This is hierarchical, right? So you can put. Maybe you have a Subflow within a Subflow within a Subflow, and then the 4th hierarchy level, that's where you have your devices. Say if you want to group your devices by building, and then in a building Subflow, and then you put different building Subflows into a site Subflow. So you can manage projects that way, or you can import and export. You can have save the flows in a library. So I guess it depends on what the size of those projects, but having different applications run in different devices. I mean, as I said, here, for example, I picked the 5 devices, right? But say this is a different application, I can pick a different set of devices. I can pick this one and that one, and now this application will also run in just those 2 devices, alongside whatever I selected here. So there's complete flexibility in terms of how you organize your work. You can organize it however it makes sense for your particular application, your particular situation.
Yeah, thanks. So the next question is, how about GPU support at the edge?
Yeah, that's also support. I mean, it's as long as the operating system supports it, we can use it too. If there's a module that has any library specifically that needs to be installed that we don't provision by default, just let us know and we install it. But in general, that's not a problem.
Yeah, we have some NVIDIA
Yeah.
Jetson devices that we use. So the next question is, how do you handle gateways that control multiple edge devices? So in this case, I guess it's not clear to me if those edge devices are the ones that we can put in Designer, or maybe those are low power edge devices. But my understanding is that maybe you have gateways that control another set of devices.
I guess I would have to know a little bit more about what the architecture looks like. But in general, as long as the say the MQTT port is forwarded to Designer, then that will be transparent. If there's a level of processing on the gateway, you can treat it as another edge device, right? You can install the agent there, our agent there, and then there's another edge device that happens to be communicating with a subnet. So again, that's also possible. It really depends on how you want to organize your network.
Yeah, so I think if I could elaborate a little bit, if you have like little devices that are low power microcontroller devices, we don't program those, but those can speak to a gateway, or those can go to Designer directly through say MQTT, and then you can program your gateway, process the data coming from the edge devices. If your edge devices are able to run Node-RED type of applications, then both your gateway and all those edge devices can directly be inside Prescient Designer. Maybe that's, I don't know if that clarifies things a little bit.
Yeah, so if the sensors connect directly to that gateway, I guess you would run the Prescient Edge on that gateway. So again, it's hard to tell with so few details, but in general, other than, yeah, so if there's a microcontroller, you probably want to wrap it around a way to handle it. If the micro-based edge device has MQTT built in, that's totally fine. Then you can run an MQTT server on the local on the gateway. There's many ways to address this, and all of those are supported.
Yeah, great. So I'd like to thank everyone for attending. If you have any questions, if you have any feedback, please ping us. We're always happy to see different suggestions and feedback. If you have projects, if you think this could be useful for you, please ping us. We're happy to chat. We do have a short, I think, feedback. What is it called? It's not called a
survey
here anymore. Survey, yes, after we close the session. So if you have just a minute, please help us to provide some feedback. Thank you so much for attending. And if you have any ideas on what we can do for our future webinars, also please provide in the survey. Thanks a lot, everyone.
Thank you.